Yes, sir.
Okay, so we'll start the machine design 1. So yesterday I sent an video so to go through the syllabus. So it has an 4 units. First unit, introduction, which includes design for static and impact strength. Second unit, it is designed for fatigue strength, and another one chapter is there in second unit. There is what a design of threaded fasteners. Third unit, design of shafts, quarter joint and knuckle joints, keys and couplings. Okay. Fourth unit is the design of riveted joints and welded joints. So before we want to start this one, let us understand what is the meaning of machine design here. So machine design is defined as the use of scientific principles. So first is what use of scientific principles. Second one is so technical information. Along with imagination. Along with imagination. Now using all these options, if you want to create a component or if you want to create a machine or element, so you need to include all these three factors. That is what important features. Now after including all these three, so it has to perform the specific functions with maximum economy and efficiency. With maximum economy and efficiency. So that means you can say machine design is defined as the use of scientific principles, technical information and imagination in the descriptions of a machine or a mechanical component or a mechanical system to perform specific functions with maximum economy and efficiency. So now this is what the definition of machine design. That means it should include the scientific principles which are there. Example, so Newton's laws, Bernoulli's equations, Pascal's laws. You need to use all those scientific principles along with technical informations. Technical information includes, so what is the type of mechanisms you are going to use, or what is type of drivers you are going to use to perform its functions. Similarly, you need to go for imaginations. So how the different situations are going to occur and what are the different type of components you are going to use. Okay. So that is what you need imagination. So after inclusion of all these three, so the performance or functioning of that particular machine has to be of maximum economy and efficiency. Okay. That means so it should be completed with a minimum amount of money, as well as it has to provide the maximum efficiency. Okay. So that is what definition of machine design. Okay. Now if you look over the Shigley's model for design, so normally it includes the 6 steps. That is what first you need to find out recognition of need. Second step, you need to define the problem. Okay, that is what a definition of problem. So third step is you need to go for synthesis. So fourth step you need to go for analysis and optimization. So fifth one you need to go for evaluation. So sixth is what of presentation. Sixth is presentation. First is what you need to collect the problem definitions. That means the what is the recognition of need, or what is the requirement of the society, or what is the requirement of a particular person, or what is the requirement of a particular company. So then based on those need you need to define a problem here. Okay? Definition of problem. Okay? So next, after that one you need to go for synthesize it. So whether what type of the components you need to adopt here, what type of mechanisms you need to adopt. Okay, so to fabricate or to construct that particular machine. Okay. Once the synthesis is done, then you go for analysis. And analysis, what happens? So you need to check out all the functionality, all the working, and all the mechanisms which are related to one another. Okay. So once analysis started, along with analysis you need to go for optimization. So optimization means whether is it possible to reduce the extra components or extra drivers or extra, so the machine elements which are there. Okay. So then after evaluation, once you completed analysis and optimization, then you go for evaluation. So if evaluation is success, then you go for presentation. Otherwise, if anything is not satisfied according to your requirement, so then you need to go for some re-steps here. That means you need to go back to your previous steps. Okay. So synthesis there. Okay, I will just show analysis and optimization, then evaluation, then presentation. Okay. Suppose if a defined definition is not satisfied, it is not going to match with, again you need to go for checking out the recognition of need. So whether have you missed any requirement or have you missed any approaches which are there in need. Okay. So again you need to, based on recognition, you can redefine the definition of problem. Okay. Next, so synthesis, if it is not going to include the mechanisms as well as the defined components, then you can go for again selection of the synthesis based on the recognition of need. Okay. Here all are related. Now if you come to the last step, that is what evolution. So in evolutions you are going to get the all functionality, just like evaluation means it is a result. It is a result. If it is not satisfied, so the evaluation may lead to change in analysis and optimization, or the evaluation may lead to change in the synthesis. Okay. So the evaluation may lead to change in the problem definition. Okay. Similarly, so analysis may be need to change again to the definitions of need as well as the recognition of need. Okay. So this is what the Sigley's model for design. So you are going to get a 6 steps here. You are going to get a 6 steps. One is what? Recognition of need. Okay. So another one is what? Definition of a problem. This is what? First, second. So all are correlated here. Okay. All are correlated. So third one is what? Synthesis. So fourth one is analysis and optimization. Fifth one is what? Evaluation. And sixth one is what? Presentation. Okay. So you can refer any one books for this Sigley's machine design. Okay. or it has got the flow chart or steps in design of machine elements. Okay. Now, the basic requirements. So, what are the basic requirements of machine elements? So, can someone say what are the requirements of machine elements? Machine elements again requirement irtada. ಏನು ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇರಂಗಿಲ್ಲ. So, first it should have a strength, second it should be a rigidity, next it should be wear resistance, so minimum dimensions, it should have a minimum dimensions. So, it should be manufacturability, that means, so you can go for easily manufacturing, that is what manufacturability. So, next is a safety, next is safety. So, next conformance standard. Next, it should be reliable. It should be reliability. So, next maintainability. Next, minimum life cycle cost. So, strength is required. Strength is required. Why strength is required? Strength is required to avoid failures. Okay. Suppose if you are designing an element which is to carry the 20 kilonewton, okay, so it should sustain 20 kilonewton. Okay. It should sustain 20 kilonewton. That means, if you place a load of 15 kilonewton, so it should not be break or it should not damage. Okay. So, to avoid failures, it should be have strength. Okay. Next, rigidity. So, should not deflect or bend. Okay. Should not deflect or bend. Okay. So, there should not be any deflection, okay, or should not be any bend when it is subjected to load. Okay. Subjected to load. Next one is wear resistance. So, as I seen, lot of components are in a friction, which are moving related to one another. Example, if you consider an IC engine, so we have a cylinder and piston. Okay. So, as a lot of reciprocating motions takes place between the static cylinder as well as piston. So, wear is going to occur. Okay. So, that means, so it has wear resistance. It should have a wear resistance. Okay. So, if a wear resistance is not there, so you are going to get loss of accuracy. So, it should have a minimum dimensions. Okay. Minimum dimensions. Okay. So, minimum dimensions as well as minimum weight. It should have a minimum weight. So, example, suppose you are designing a key for a shaft, okay, for a shaft. This is what key. Now for diameter of 50 mm, for diameter of 50 mm shaft, okay, so the size of key should be minimum here. Key dimension should be minimum. Example, if you consider the standard relations for a square key, the maximum size provided for 50 mm diameter is, okay, 50 mm diameter is 12.5 mm by 12.5 mm. It's a square key. It is a square key. Okay. Now the dimension what you are going to select should not be more than 12.5 mm, okay, should not be more than 12.5 mm, okay. So if it is more than dimension, automatically what happens, weight is going to increase. As the dimension of this key increases, weight is going to increase, automatically cost is going to increase. That means, so the machine element should be of minimum dimensions and minimum weight. So next, manufacturability. So manufacturability. Now this is what it should be ease of fabrication. It is easy to be fabricate, as well as it should be easily assemble. It should be easily assemble. Okay. So it should not provide any difficulty for assembly purpose. Okay. And it should not be not too much complicated for fabricating. Okay. It has to be easy to fabricate as well as easy to assemble. Next one, safety. Okay. So the machine element should ensure safety to the operator. Safety to the operator. So it should provide safety for operator. Okay. Next, conformance to standard. Okay. Conformance to standard. So now, as you need to use some particular type of machine elements, so it should be related to the international standards. Okay. Example, if we take a gear, or if we take a ball bearing, or if we design any ball bearing, or if you design the roller bearing, okay, so it should meet the international standards. It should meet international standards. So otherwise what happens, so if the element is worn out, or if the element is damaged, or if the element is broken out, so it should be easily replaceable. Okay. ಸೊ ಅದೇ ನಿಮಗೆ ಎಲಿಮೆಂಟ್ ಡ್ಯಾಮೇಜ್ ಆಯಿತು, ಮುರಿತು, ಕಟ್ ಆಯಿತು ಅಂದ್ರೆ ಅದನ್ನು ನಾವು ಈಸಿಯಾಗಿ ರೀಇನ್ಸ್ಟಾಲೇಷನ್ ಮಾಡೋ ಥರ ಅದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸಿಗೆ ರಿಲೇಟೆಡ್ ಇರಬೇಕು. ನೆಕ್ಸ್ಟ್, ರಿಲಯಬಿಲಿಟಿ. ಸೊ ರಿಲಯಬಿಲಿಟಿ, ಸೊ ಇಟ್ಸ್ ವಾಟ್ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಆಫ್ ಫಂಕ್ಷನ್ ಸ್ಯಾಟಿಸ್ಫ್ಯಾಕ್ಟರಿ. ಸೊ ಈ ಒಂದು ಎಲಿಮೆಂಟದ್ದು ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫ್ಯಾಕ್ಟರಿ ಇರಬೇಕು. It should be satisfactory. Okay. So because what happens, if one element performance is not satisfied, the entire machine is going to be stopped. Entire machine is going to be stopped. Okay. So it should perform satisfactorily throughout its lifetime. Throughout its lifetime. Okay. So if you say, if we have a gear train, okay. So what happens, if one gear is going to be worn out, then the gear drive is idle. Entire drive is idle. Okay. If the drive is idle, so then the all elements which are related to this drive, are going to stop. That means entire machine is going to be stopped. That should, right? So that is what it should perform its function satisfactorily over its lifetime. Okay. So next, maintainability. So it should be easily maintainable. Okay, so where the machine elements or machine parts can be easily replaced or easily served. Okay, so easily served. Okay, suppose if it is a damaged or if it is a worn out, so that should be easily replaceable. Easily replaceable. So next, minimum cycle cost. So the overall cost for its performance or for its working, it should be minimum cost. Okay? It should be minimum cost, not more than that. Okay? Now this is what the basic requirements of machine elements. Okay? So next bit is, so design of machine elements. You have come across the what is a machine design, what is the Sigley's flow chart for design, then some basic requirements of machine elements. Okay. So now what is the design of machine elements? Okay. So let us go for one flow chart is here. Okay. Design of machine elements is different, machine design is different. So don't get confusion, both are same. Okay. So if you say machine design, okay. So this machine includes lot of elements here. This machine includes lot of elements. It is going to be include lots of elements. Let us take these are the elements. These are the elements. Okay. So now you need to go for individual machine elements design. That is what design of machine elements. I will go for again example. Let us consider an IC engine. Let us consider an IC engine. So the major parts you are going to see in an IC engine, it is what? A piston. Okay. So piston, then cylinder here. Okay. So just I am go here a rough diagram. Okay. So cylinder. So now in this cylinder you are going to get a crankshaft. You are going to get a crankshaft. Then you will have a connecting rod here. Okay. So what are the elements you got? One is connecting rod, here. Okay. So next, this is what piston. So now this is what piston. Okay. So next you have a piston pin here. Let it be. Now this piston is going to be attached with some rings, piston rings. Okay. Next you have a connecting rod. So next you have a crankshaft here. Now in this case IC engine is what? It is a machine. IC engine is a machine. Now piston rings, connecting rod, crankshaft, piston head. Okay, this is what head, piston pin. All these are elements now. All these are elements. Okay, IC engine is a machine. Piston rings, connecting rod, crankshaft, piston pin, head, piston rings. Okay, sorry, piston. And then you have some inlet valve here, so exhaust valve. So now all these are machine elements. Okay, all these are machine elements. You got a clear idea? Machine design is different. Design of machine elements is different. Okay, so now you are designing machine elements, not a machine complete design. Okay. Now what is the first step here? So you need to specify the functions of element. You need to specify functions of element. Okay. So once you specify the functions of element, next step is you need to determine the forces acting on the element. Determine the forces acting on the element. Okay. Next, so once you got functions of element, once you got the forces acting on the element, then you need to select the material suitable for that element. Okay. Third one is select suitable material for element. Now, once you selected force, once you selected material, then you can easily find out the what are the failure modes based on the force as well as the material properties. Okay. So, determine failure mode of element. Okay. Mode of element. Okay. Example, so whether the component is subjected to twisting movement, whether the component is subjected to bending movement, or whether the component is subjected to the direct loads. So, based on that one you can decide. So, what type of failure mode is going to take place. Okay. Once you decide failure mode, then you go for determine geometric dimensions of element. Determine geometric dimensions of element. Next, once you got the dimensions, so next you have a chance to get out the modification of dimensions. Okay. So, next is what? So, modification of dimensions. So, for assembly, okay, for assembly and for manufacturing purpose and for manufacturing. Okay. And also you can check for critical design for critical cross sections. Okay. So, and check for design, okay, at critical cross sections. Okay. Because what happens, so as you are going to change the dimensions, as you are going to modify the dimensions for ease of assembly purpose, so the cross section may going to reduce, the cross section is going to be reduced, sometimes the cross section is going to increase. Okay. Again you need to recheck whether it is going to satisfy or not. Okay. So, once it is going to satisfy all the functionalities, all the failure criteria, so then you go for preparation of drawing. Prepare drawing, okay, of element. So, what is first step? First step, you need to specify functions of element. Next, you need to determine the forces acting on the element. Okay. Next, select suitable material for element. Next, determine the failure mode of element. Okay. So, next, determine geometric dimensions of element. Okay. So, next, if possible, modify the dimensions. Okay. Modify dimensions and check it for again critical section. So, last step is you need to go for drawing. Okay. Last step is you need to go for drawing. Okay. So, now it is a flow chart. Okay. It is a flow chart. Okay. So, you need to follow the same steps. So, you should not select somewhere intermittent. Somewhere intermittent. Okay. So, if you consider in this case as the connecting rod as our element. Okay. For understanding purpose, now we will take a connecting rod as an element. Okay. So, now connecting rod is subjected to what? So, it is subjected to oscillating loads. It is subjected to oscillating loads. So, so as it is going to make oscillation, so the maximum it is going to be subjected tensile. Okay. One time it is going to be subjected, another time it is going to be subjected to compressive. That means, so now the connecting rod is subjected to fluctuating loads here. It is subjected to fluctuating loads. So, what you got? You got the determination of forces acting on the element. What type of forces is subjected? One time it is subjected to compressive load, one time it is subjected to tensile load. Okay. Now, as you know the forces, then you select suitable material for this crankshaft. Sorry, this connecting rod. What type of material? Whether you are going to go for cast iron, whether you are going to go for the alloy material. Okay. Whether you are going to go for alloy cast iron. Now, once you selected the material, so related to material, you have certain properties in data handbook. Okay. Properties in data handbook. That is what you have a ultimate strength, you have a yield strength, and you have a suitable factor of safety. You have a suitable factor of safety. Okay. So, now using all those things, so you can find out the dimensions of the connecting rod. Dimensions of the connecting rod. Okay. So, this is how the machine design, design of machine elements takes place. Okay. Now, this is what the overview of the machine design as well as design of machine elements. Okay. Next, we will start the syllabus. Now, first one is normal stress. Can someone say what is the meaning of stress? Stress andre enro? Stress andre enro? ಮಕ್ಕೊಂಡ್ರೆ ಹೊಸರು ಏನಿಲ್ಲ ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೆ ಮಾಂತೇಶ ದೊಡ್ಡ ಮನಿ ಮಾಂತೇಶ್ ದೊಡ್ಡ ಮನಿ ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೆ ಏನಪ್ಪ ಹುಟ್ಟಿಗೆ
The force acting on element at a particular area. In particular,
force acting at element a particular area. ಮತ್ತೆ ಬೇರೆ ಮೀನಿಂಗ್
force acting on a body.
ಹೇಳೋರು ಆಟೋಡ ಏನ
Sir, tangential force acting on a body at a particular area, sir.
Tangential force acting at a body particular area. ದೊಡ್ಡಮಣಿ ದೊಡ್ಡಮಣಿ ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೇನು ಮಾಂತೇಶ್ ದೊಡ್ಡಮಣಿ
ಹಾಂ ಸರ್.
ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೆ ಏನು? ಕ್ಲಾಸ್ ಕೇಳಾಕತ್ತಿರೋ ಸುಮ್ಮ ಆನ್ಲೈನ್ ಟ್ರೈಲರ್ ಹೋಗಿ ಕೂತಿರೋ?
ಇಲ್ಲ ಸರ್, ಕೇಳತ್ತೀವಿ ಸರ್.
ಯಾವ್ದು ಸರ್?
ಓಕೆ, ಆಫ್ ಮಾಡ್ರಲ್ಲ, ಮೈಕ್ರೋಫೋನ್ ಆಫ್ ಮಾಡ್ರಿ. So normal stress, now stresses, you are going to get a different type of stresses here. Okay, so normal stress is defined as when a component is subjected to axial loads. When a component is subjected to axial loads, then you can say it is subjected to normal forces or normal stresses. So let us take an example here. Okay. So it is a rectangular bar. It is a rectangular bar subjected to tensile load P. Subjected to tensile load P. Now what happens? As the load is subjected to tensile, now its length is going to increase after application of load. Length is going to increase. Okay, length is going to increase. So other dimensions are going to decrease. Now this is what before application of load. This is what after application of load. Okay. Now for understanding purpose, what I will do, I will make a section of this body. Okay. So I will make a section of this body. Okay. Now let us consider this top portion. Let us consider this top portion. Okay. So if you consider top portions, right, P. Now as you are applying the external load to this element, it is going to be creating a resistance force inside it. ನೀವು ಹೊರಗಡೆಯಿಂದ ಎಷ್ಟು ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡ್ತಾರಲ್ಲ ಅಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಫೋರ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ ಕಾಂಪೋನೆಂಟ್ ಒಳಗಡೆ. ಸೊ ಬಿಕಾಸ್ ಇಟ್ ನೀಡ್ಸ್ ಟು ಸಸ್ಟೈನ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಲೋಡ್ಸ್. It needs to sustain the external loads. To sustain that external loads, so the resistance force is created. Okay. Resistance force is created. Okay. Now for equilibrium condition of this particular section or this particular bar, okay, for equilibrium condition, what happens? So for equilibrium conditions, the summation of forces should be equal to 0. Summation of forces should be equal to 0. Okay. So what happens? So the applied force is equal to the resisting force which is generated. Resisting force which is generated. Okay. Let us take this as a RF is a resisting force. P is the external force. Now the normal stress is defined as resistance offered by a body against the deformation per unit area. Per unit area. Okay. So now you can say stress is the resistance offered by a body against the deformation per unit area. So now this stress is noted with the different notations. Some book they have gone for small f, some book they have gone for a small p, some they have used an sigma. Now this is the notation for normal stress. Okay. So let us take sigma t is the tensile stress. Okay. Now what is the resistance force? RF is the resistance force per unit area. per unit area. So, as seen based on equilibrium conditions, so external force is equal to the resistance force which is developed. So, now you can replace this Rf as a P by A, P by A. So, now P is what in terms of Newton, A is in terms of mm square or meter square. So, now stress is what you can say. So, where delta T is tensile stress, okay. So, P is external load or external force, okay. A is cross sectional area. Okay. So, this stress unit is Newton per meter square or Newton per mm square or Pascal or megapascal or gigapascal. Okay. So, Pascal is what? Newton per meter square, okay, 1 Newton per meter square. So, now this is what a definition of normal stress. Okay. So, in normal stress you are going to get a two type here. One is tensile stress, okay. One is tensile stress. So, diagram what I have noted, it is a tensile stress. So, how we can define tensile stress? It is defined as when the fibers of component tend to elongate due to an external force in force direction, in force direction. So, I will take example here. Subjected to load P, subject to load P. As apply the load, now diameter is going to decrease, diameter is going to decrease, length is going to increase. Okay, clear? So, the tensile stress may be defined as, so fibers of component tend to elongate along direction, along direction. Compressive stress, similarly compressive stress. ಏನು ಹೇಳ್ತಾರೆ ಇಲ್ಲಿ ತಮ್ಮ So, in compressive stress what happens? in compressive stress, the fibers of component are tend to compress or tend to shorten in low direction. Okay? In low direction. So let us look out. So if the compressive load applied, now this is what, now what happens here, length is shortened, other dimensions are increases. Okay. So you can say, so fibers of component tend to decrease due to external load, external force or load, okay, along the load direction. Okay. Right. So I stop here. I will go for again at a 4 o'clock class. Okay. So only 7 members are present. I will take attendance daily. For every session, I will take attendance. So, you have any queries? You have any queries?
No, sir.